So we're going to try to talk today about two components of Java. One is Java types, and I just want to make you aware of some issues on the tape side, and particularly introduce this enums. I personally think enums are really useful and handy in models for a lot of purposes in health, and so I'd like to introduce this construct so you know that they're available and are aware of them. The second thing is, if we have time, I'll try to get to issues of functions, defining functions, and how we use them. But we may just have to confine ourselves to Java types and enums. Okay, so we've seen types before. Types in Java. Types are the indications we give or denotations we give that indicate what sort of information a parameter or a variable, for example, can hold. And I need to get up my AnyLogic. I was fooling around with AnyLogic 7 here, so I need to get up AnyLogic 6. There we are. We saw before that we have to associate things like whether something is a double, or something is an int, or something is a Boolean. And as a language, Java forces you to be quite specific about what sort of information is held by a given variable, or by extension can be returned. In other words, the type associated with a value. So if a function returns a value, you need to label what does it return. If it takes information in this so-called parameters, the information to do its job that's required, you have to give that type. If a variable is declared, you have to specify what type of values it can hold. What's the type of those values? And same thing with parameters. So here we have types that need to be specified for a bunch of areas of our model. And for a given type, the fact that a value is of a given type limits what you can do with it. So for example, you cannot subtract one string from another. You can't multiply a Boolean. There's only certain things you can do. You can't say if a double value, or even if an int. You can't do this in Java. So a Boolean, for example, you can test whether it's true. You can turn it into a string. A null precision value can be divided, multiplied, or turned into a string. A reference, you can dereference it. You can get information. If you referenced a person, you can ask what's their income. You could call a method on it. But you could also turn it to a string, for example. And we'll see this in they can be turned into a string really nicely. So there's a bunch of types that Java provides automatically to us. Booleans, doubles, shorts, ints, chars, bytes, ons, floats. These are all provided automatically to double. You really, and as part of Java, you really only need to know about Boolean, double, and int, really. I mean, Java makes some use of shorts to name states, but that's all you really need to know. These first four at most, probably the first, second, fourth. Okay. And int holds values that are in the integer range, so this includes negatives and positives. And Booleans hold true or false, doubles hold double precision values. Okay. Now, most types we use are actually not primitive types. They're defined. They're things like active objects, or person, or agent continuous 2D, or string, or something like that. Okay. So why do we use types? Why does Java so insistent on types? Because it helps AnyLogic find problems with our models sooner. Instead of it blowing up while we're running it, those problems are found before we run the model. And it says, I can't do that. Fix it. The alternative is, you may be running your model in a nice long run. It's taking 3 days to get some results for a paper, and then it blows up in the middle of it. Because some condition was very unlikely to occur, like the Brevi zebra went to the corner of their enclosure pooped or something like that, and then it blows up. And believe it or not, like you may have an if statement under this weird, like if the agent is outside its bounds, do this other thing, and it's only hit occasionally, and it blows up then. And actually, having types lets it find mistakes sooner. Okay. The trade-off is that sometimes it flags something as a mistake that's actually not a mistake, and you have to kind of say, hey, do what I told you to, go ahead and do this. I know what I'm doing, and so on. So there's a thing called casting that allows you to say that, look, I have something of this type. I want to convert it to this other type, and I know what I'm doing. I know it can be converted. Okay. So, for example, so there's some things in AnyLogic where we have a person, and we ask, get my nearest agent. Okay. So suppose I'm in space. I'm moving. That sounds weird. Suppose I'm moving around in some continuous space, and I want to say, tell me my nearest agent. And it's only persons in my model set. So I know that the nearest agent that's given to me is going to be a person also. But actually in Java, and the way AnyLogic is built, you say get the nearest agent. They don't know what you're going to be naming your agent, so when they have a method called get nearest agent, it actually returns a reference to an agent. They don't know that it's a antelope. They don't know that it's a person. They don't know that it's actually going to be a doctor. They couldn't anticipate that. It's called an agent, and it turns out, as we'll discuss tomorrow, your person is actually what's called a subclass of agent. In other words, it's just a special subtype of that. It's an agent, but it's also something more than an agent. Just like a professor is a human, at least I like to think so. A person is an agent, and so, but they didn't know what you'd be calling it, so they say get nearest agent returns an agent, and you have to tell it, well, treat it like a person. It's actually a person. Go ahead and do it. We get other cases like that. So we have a double precision value, and we want to treat it as an integer. We want to drop the fraction component. When we have an integer, and we want to convert it to a string, we want to print it out or something. And as I said, we have an active object or an agent. We know it's a person, so we treat it as a person. How do we do that? We do it through this sort of thing. And you'll see these things occasionally in the model. You'll say you have some value. Maybe this is a long expression. Maybe it's an explicit value. And then you say, and you have this thing in parentheses in the name of the type. Okay. So maybe V is an agent, and you say person in parentheses, meaning treat this guy as a person. Originally he's an agent, but I know he's a person, so treat him that way. Okay. Here's an example. So you have an age. You need to treat it as a string for it to print out, something like that. You want to take the current age, which is maybe a continuous variable, treat it as an integer and add 1 to it.
So there was at least one of the models that we tried to run today in class, on 6.9, had a freak out because it thought it was a double and it needed to be an integer, and you put in the casting thing and it works
Put in the
fine.
casting thing and it works fine. That's what you do. So most of them, you want to be clear, you want to be sure that's what's needed. But I mean, you can test it and then really, really think about it if it does fix the issue. But a lot of the time, this is what's needed. So here we may have an agent as item. We have this big population. An item is just one person in the population. We happen to know from the context maybe that they're female because we tested first that they're female, and then we say, okay, now we want to ask, okay, given that they're female, they're pregnant. If so, we say, okay, treat them as a female, and then ask ask their state chart if they're pregnant. Okay. So here we know what we're doing, so treat it as a female. And by the way, if in fact it's not female, when we're running our model, say, it's expect to be female, it's not, and so it will give up the ghost. Okay. I could talk about this, but time is short. I think I'll skip this in as much, except to mention that there are certain types of types that are that have sub pieces that are of another type. So, for example, we have a collection of person, or we have a collection of deer, we have a collection of cars, or something along those lines. And in Java, in AnyLogic, if you have a model, if you have a model in AnyLogic, which has a collection in it, let's go see how these collections go. Let's go take a look at person here in my ABM model with birth death, which by the way illustrates several somewhat more advanced things, or at least intermediate level things. Here's children. We did this yesterday. When was it? The day before yesterday, whatever it was. Here's a collection. This is a collection. That's why it's shown that sort of thing. Remember that? When someone gave birth, we added them to a collection. It's a collection. This is an array list, and it's an elements. This is an array list of something. It's a bag of some things. What's in the bag? And so this bag is of coins. This bag is of of papers. This is a bag of dumb or something like that. This is what's inside of it, and that's what's called a parameterized type. So it's an array list of something. And it turns out a fair number of things in Java are that. They're like an array list of this thing. Okay. Anyway. Okay, so yeah, this is how we sort of describe them. So array list of double. So that would mean it's keeping track of doubles, or a list of deer, or a set of persons. These are all things you can build in Java. You have a set of persons. You could ask, is this set empty? Is this set a superset of this other set? You could take the union of two sets, or what have you.
So, sorry, what's the, maybe this is a very silly question, but what's the difference between sets and say, populations and
Right.
Parts?
It's a good question.
It's subpopulations.
So a set is so those have commonalities in that they're both collections. They're both collections of things, but a population is more structure to it. It actually has an ordering. So you say there's person 0, person 1, person 2, whereas a set is unordered. They're just some group, and there's no ordering. There's no this person before that person is part of the set.
But isn't it the order of the population is random anyway?
It's arbitrary, but once it's established, you can always get to the same person by asking the same thing, as long as they haven't died. Does that make sense? Yeah. Not that I normally depend on that, but occasionally it's useful. Okay. So like person who was at the front of it before, as long as they haven't died, they're still at the front of it. Okay. This is somewhat more advanced stuff, but when you see these brackets like this, just be aware it's like we're saying this is a pair of a string and a double. It's like a pair of them. One comes first, one comes second. This is a resource pool of some resource unit. This is a list of persons. So it contains persons. This is actually fairly intermediate Java, but you see it enough in AnyLogic. I just wanted to inoculate you against this, so you don't get scared if you see this. You won't be writing these things. I almost virtually never sort of write anything like this, but occasionally I'll see it in Java, and it's important that you not be, just think, I don't know what this is. It's too weird. It's actually something sensible. Sorry, I don't mean to impose things, but okay. So actually, yeah. So like an experiment is an experiment of a class. This is a little bit confusing, but if you notice the experiment, if you ever noticed, like if you go down to this, here's the experiment, and you notice it says like, what is this? It's like, okay, what is the main thing? What is it based around? This, in other words, this experiment is based around some main class, some model. That's because it needs this in there. Whichever class you tell it, that's the one that's there, and that little drop down. A resource pool, you'll see this of resource unit, a network resource pool. This is so they can move around in space. Active object array list, you'll sometimes see this, and active object list. So yeah, so these things occur. Okay, so here we have, like in this this network modeling where we have people moving around. Remember I showed you that little example where people were getting sick and they were coming into the clinic and they were getting serviced by doctors. Remember I did that earlier today? So here we have resources for that. So we have doctors, say Procrum and Scope. This is an ophthalmology model you'll find where I give a lecture on this online. 2 lectures, I think, on YouTube on this particular model in a row, talking about how it works. So you'll notice here it says network resource pool, T extends resource. So this is something that's a network resource pool and has some resource units in it. You shouldn't have to know about that much. Okay, this next thing I think is really useful. Okay, it's intermediate level stuff, but it's useful enough in health modeling that I recommend it to my students. So there's this thing called linear. It allows us to. So I'm gonna stop this and create a nugget.